Hello everyone, this is Dr. E, and for today we're going to be analyzing function without the use of Desmos or graphing calculator. Analyzing function analytically or using algebra is one of the challenging skills that we learn in algebra. And that's what we're going to be working on today, on how to identify or visualize the behavior of a function or polynomial function without the aid of technology. And for functions like x cubed or x squared or x to the first power, these functions are being categorized according to its degree or highest exponent, and we call this in algebra as the power of the function. So a power of a function of degree n is of the form f of x is equal to ax raised to n, where n is going to be a positive integer. So the exponent will determine the behavior of your function or the degree of the function, and this is what we're going to be working on today, starting with our linear function, which is a function of degree 1. So a function of degree 1, it means that the highest exponent of the function is 1, and in this case 2x plus 7 has the highest exponent of 1. And if we're going to graph this manually, we know from our previous lesson that graphing f of x equals 2x plus 7. We have the y-intercept as 7, so this is the y-axis. 1, 2, 3, 4, 5, 6, 7. And our slope is positive, and it's going to be positive 2 over 1, which means the direction of our second point will be 2 units up, 1, 2, and then 1 unit to the right. So this is where the second point lie, and if we sketch the graph of our linear function by connecting the dots, we are creating a line, a diagonal line that is increasing. So this is another way of describing our line or n behavior, and we know that this is increasing because from negative to the positive side of the number line, our line is going to the positive direction. So that is how we determine a line or a function graphically and how we describe it using its degree. So this is our linear function, and as stated, this is our y-intercept and the slope is positive, so the diagonal line is increasing. So this is how linear function or most linear function will look like. It's increasing or it's positive going upwards, and it's determined by the sign of your slope. So that means if I have f of x is equal to 8 minus x all over 2, for some students, this may be a little bit challenging or confusing if this is a degree 1 polynomial because of our fraction. But if we modify this function into f of x is equal to 8 minus 1/2 x, we can confidently say that this is a function of degree 1. So this is a line that is going downwards this time, and it's downwards because our slope is negative. And if we translate this into our graph using our skill of graphing a linear function manually, this is the y function. Our y-intercept is at 8, 1, 2, 3, 4, 5, 6, 7, 8. And the second point is determined by the slope, which is negative 1 all over 2. So that means you are going to move 1 unit down to the y-axis and 2 units to the right. 1, 2. So you're always moving to the right. So the only movement that is changing when you are doing a linear function is going up or going down, depending on the sign of the slope. So this is now the rough sketch of our linear function, and we know that this is decreasing because our function is going downwards, starting from the negative direction going to the positive direction. So this is how we analyze a function using the y-intercept and the slope, which is negative 1 all over 2. So now that we know that our function of degree 1 is a linear function, so most or all or almost all degree 1 polynomial will have a diagonal line, either increasing or going upwards, or decreasing or going downwards to the negative direction. And the next polynomial function that we're going to be analyzing is going to be a degree 2 polynomial, also known as a quadratic function. So this one is a quadratic function because the highest exponent is 2, so we have 8x squared plus 4x. And in this particular case, we can say that since our quadratic term is positives, which is 8x squared, so that means this parabola is opening upward. So all quadratic function or degree 2 polynomial, it's either a parabola going upward or a parabola going downwards. And you can determine it without using a graphing calculator by looking at the sign of its coefficient. Since the coefficient is positive, our parabola is going upward, and when it's negative, it's going to go downward. So if we graph this function, it will be a parabola opening upward because the quadratic term is positive. Therefore, if we have negative 4x squared plus 2x minus 5 without using a calculator or Desmos or any technology to graph our function, since it's a degree 2 polynomial where its coefficient is negative 4 this time, if we graph this, it's going to be a parabola going downwards. So this is how we analyze a quadratic term. And the behavior of our polynomial, it changes according to the degree of the polynomial that we are seeing. So degree 1 is a line. Degree 2, it's going to be a parabola opening up or opening down. Now, what about a cubic function? A cubic function is a degree 3 polynomial. So depending on the sign of the coefficients of your cubic function, the behavior of your graph will change. But is it going to be a line or a parabola? And the answer is the behavior of a degree 3 cubic function will behave something like this. So instead of looking at it as a parabola like this, a cubic function or a degree 3 polynomial, you either have a tail that is opening on this opposite side of your number line, or it could be on this direction. So that is how you will visualize a cubic function. So this one, you will notice that in this cubic function, the right end is going upward and the left end is going downward. And if we have another cubic function similar to this one, their behavior is the same because the right end is going up and the left end is going downward. And when this happens without using a graphing calculator, we can say that the coefficient of our cubic function is positive when the behavior of your right end is going to the positive infinity, going upwards, and the left end is going to the negative end or negative infinity for this particular cubic function. Because when this coefficient is positive, the behavior of our cubic function will always stay the same. And if we have this cubic function, and you will see that the left end is going up this time and the right end is going downward this time around. So if we have another set of cubic function that has the same behavior, we know that this is no longer a positive coefficient for our cubic term. This time, the cubic term is negative. So without seeing the graph, by just looking at the function, we know that the graph of that function will behave like so. So for example, if I have f of x equal to 7x to the third power plus 2, if we graph this function, just the sketch of this function, since this is a positive coefficient, so that means the behavior of our function, the right end is going up and the left end is going downwards. And again, this is not an accurate representation of our cubic function. It's probably or should be a cubic function with the y-intercept at positive 2. So if you want to make it a little bit more accurate, we'll do it this way. So this is how the cubic function determines the behavior of its graph by looking at its coefficient, if it's positive or negative. So this is how the cubic function works, and how we can say if those function has a positive or negative slope, positive or negative quadratic term, or positive or negative cubic term without using a graphing calculator. Now, we're going to determine whether a function is odd or an even function using algebra. So how are we going to determine that? We have three conditions that we're going to be using. The first condition is that if f of x is equal to f of negative x, it's even. And if f of negative x is also equal to negative f of x, then it's odd. And if f of negative x is not equal to the opposite of f of x, or negative f of x, then it's neither odd or even. So let's have some examples on how we can determine if the function is odd or even without using a graph. So we have three functions right here. We have x to the fourth plus 3x squared, x to the fifth and 3x squared, and x to the third minus 5x squared plus 2. And we're going to analytically figure out if this function is odd or even. So let's start with the first function. So by using our condition, here are the three conditions. Let's see which condition will satisfy the first one. So first, our original function is x to the fourth plus 3x squared. And our modified function is going to be f of negative x. And we're going to see if these two functions will be equal by changing our x into negative x. So we'll have negative x to the fourth plus 3 negative x squared. And if we're going to expand this so that you will visualize why it's going to turn into positive, negative x to the fourth is actually negative x times negative x times negative x times negative x. And we know that negative and negative is positive, so this one is positive x. And negative is also positive, so this will turn into a positive x. So when we multiply two positive, it will become positive. So now we know that negative x to the fourth is going to be x to the fourth plus 3. And since we have negative x raised to the 2, we know that this is represented by negative x and negative x, which is going to turn into a positive x. So we can simplify our function of f of negative x into x to the fourth plus 3x to the fourth, which is the same as our f of x. So here, we now prove that f of x is equal to f of negative x. Therefore, our function is going to be even. And that is how we determine if our function is even or not, by just using the conditions that we have in our cheat sheet. And now, let's go and see if function number 2 is odd, even, or neither using algebra. So with the same principle that we used from our first example, our original function is x to the fifth plus 3x cubed. And we're going to determine if they are the same if we introduce f of negative x. So f of negative x will have negative x to the fifth plus 3 times negative x to the third power. And if we expand negative x to the fifth, we'll have negative x, negative x, negative x, negative x, and negative x. The product of these two is positive x. The product of these two is positive x. And this will remain negative, and by further simplifying it, positive and positive is positive, and if we multiply it with this lone negative x right here, it will turn into negative. So it's logical to assume and say that every time you have an odd exponent and you are evaluating a negative function, it will remain negative, and if it's even, your negative function will become positive. So our f of negative x will now become negative x to the fifth minus or plus 3 to the negative x cubed. And negative x cubed, it's odd exponent, so it will remain negative. So we'll have negative x to the fifth minus 3x cubed. And you will notice that f of x and f of negative x are not the same, but if we modify this by factoring out the negative coefficients in our function, f of negative x will turn into negative x to the fifth plus 3x cubed. And we know that x to the fifth and 3x cubed is our f of x. So now we're able to prove that our function negative of f of x is the same as our original function f of x. Therefore, x to the fifth plus 3x cubed is going to be an odd function. So that is how we determine if the function is an odd function, by showing this mathematically. So let's see if the third example is even or odd or neither. So by using the same technique, we're going to write the original function at f of x equal to x cubed minus 5x squared plus 2. And f of negative x will turn or switch our signs. So we have negative x cubed, positive negative 5, negative x squared, plus this will become 2 times negative x to the 0, because we know that a constant has a variable of x raised to 0, and we know that x raised to 0 is simply equal to 1. So with that in mind, you're not seeing the negative x equal to 0, so let me rewrite this so that you can see it better. So f of negative x is going to be negative x cubed minus 5 negative x squared plus 2 negative x raised to 0. There. So this is 2 to avoid confusion. And now let's simplify this function. So for this, we know it will remain negative because this is an odd exponent. So we have negative x cubed minus 5. And this one, negative x squared, will become positive. So this will become x squared plus 2 times negative x raised to 0 is 2 times negative 1, because negative x raised to 0 is 1. So by simplifying it, f of negative x is equal to negative x cubed minus 5x squared minus 2. And now by factoring, let's see if it will turn into f of x. So by factoring out the negative sign, we'll have negative outside, and we'll have x cubed plus 5x squared plus 2. And you will notice that x cubed and x cubed are the same, positive 2 and positive 2 are the same, but our middle term is not the same. So that means our function f of negative x is not the same as the negative of f of x. So therefore, this cubic function is neither odd or even. So that's how we use our algebra skill in identifying the behavior of our function without using any technology and by relying on our conditions. Now, let's see how these functions are translated into graph. Why is it even? Why is it odd? And why is it neither? So if we graph x to the fourth plus 3x squared using our graphing calculator or an app like Desmos, this is what it will generate. So we have a parabola or a parabola-like function because this is a fourth degree polynomial, and we know that it's even if your function is symmetrical on the y-axis. And the y-axis is definitely showing us symmetry for this fourth degree polynomial, therefore it's even. And for odd function, we are not going to rely on the symmetry on the y-axis, but we're going to rely on the symmetry on y equal to x. And y equal to x is the function or a diagonal line that passes through the origin, and it's increasing. So we know that from here, we are seeing that this side of our function and this side of our function is showing symmetry along the line y is equal to x. Therefore, it's an odd function. Now, what about a function that's neither odd or even? This is how it will look like. So x to the third minus 5x squared plus 2. This is a cubic function. And you will see that using our first test, our y-axis test, the symmetry is no longer visible in our cubic function. And if we also checked its symmetry on y is equal to x, we can also say and see that they are not the same, or there's no symmetry on the line y is equal to x. So that is how you would tell, or you'd be able to verify if your function is neither using a graph. So our Numberbender challenge for the day. So we have 4 graphs of our polynomial functions, and your goal is to match 1, 2, 3, 4 to A, B, C, D. So see if you can match it correctly, but without using a calculator or decimals, and by just looking or using the skill that you have learned for this lesson in our functions. So that is how we visualize our graph without using a technology, which is a good way of understanding how a polynomial behaves using math or algebra. So that is how we gain confidence in working with functions and thoroughly understanding the polynomial functions that we're working on in algebra, calculus, or even trigonometry in the future classes that you're going to be working on. This is Dr. E, and see you again next time. Bye!